Good day, guys. Today we are doing laws of indices. That's our topic number 14. So we've got some prescribed laws that you are supposed to apply if we are dealing with laws of indices. I'm going to give you examples based on some of these laws. So I've got law number 1, which says anything raised to a power of 0 is equal to 1. So my law number 1, so which says anything raised to a power of 0 is equal to 1. I might say 2 to the power of 0, my answer is equal to 1, right? Then my second example, 250 to the power of 0 is equal to 1. Then my third example, if I'm to say negative 10 to the power of 0 is equal to negative 1. My law is only applicable to what? To those whole positive numbers. So my negative sign is going to, we're going to retain that a negative sign. That's our law number 1. Even if it appears in the form of a fraction, you might find a question saying, that's our number D. The question might say 2/3, then in brackets to the power 0. Your answer is always equals to what? 1. Your answer is always equals to 1. Then that's our law number 1. We're now going to what? Our law number 2. Let's move on to our law number 2. Our law number 2. I might say 2 to the power negative 3, which is equal to, this negative sign is going to be converted to become a what? An inverse. In this case, I'm going to obtain 1 over 2 to the power 3. Then I think on top there I gave you a hint. Let's try to follow that hint before I proceed with this one. As long as you are doing laws of indices, logarithms, miscellaneous equations, you are supposed to bear that in mind. You have to know 2 to the power 1 up to 2 to the power 6, 3 to the power 1 up to 3 to the power 5, 4 to the power 1 up to 4 to the power 4, 5 to the power 1 up to 5 to the power 3. You are going to see how does that apply here. In this case, so my working is going to proceed as it's equals to 1 over 2 to the power 3. This means 2 times 2 times 2 up until I reach what? 3 times. So that's 1 over 8. So this is my answer. Most of the students tend to make a mistake here and say 2 times 3. If you come across an index there, it no longer means the same as 2 times 3. It's now an index. It means we are raising this number to that index. So multiply this same number according to what? To that index. If it's 4, it means multiply the same number 4 times. If it's 5, it means multiply the same number 5 times. Let me proceed to the other example here. So if I proceed to the other example here, I'm going to say maybe number B, that's a 3 to the power minus 3. I'm going to say it's equal to 1 over 3 to the power 3. This negative sign is going to be converted into what? Into that 1. This means that this is an inverse, right? So it's going to be equal to 1 over, this is not 3 times 3, but it's 3 times 3 for 3 times, right? So it's 3 times 3 times 3. We are going to obtain what? 27. So you have to know the correct interpretation of what? Of our index. So I'm going to law number what? Law number 3. There is our law number 3, which says, I may say my number 3 there, 2x in brackets to the power 3. This means everything that is found inside the bracket is going to be affected by that power. So it's raised to a power of 3. So in this case, it's going to be equals 2 to the power 3 x to the power 3. It's equals to 2 to the power 3. That's what? That's a 8. Then I can simplify that one. It's going to be x cubed. So that is your answer. Going to the other example, I might say my B might be, I might say 3a in brackets to the power 4. That's equal to 3 to the power 4 a to the power 4. It's equal to, so you realize that it is necessary for you to know these powers. You're supposed to know these indexes just by head, so you have to memorize them. So in this case, so that you minimize your time as you will be working, especially if you're in an exam, since you'll be racing against time. So in this case, we're going to have 3 to the power 4. That's what? That's our 81. That's 81a to the power 4. So that is our answer. We are now moving on to theory number 4. We're now moving on to our theory number 4. There is theory number 4. An example. That's our theory number 4. An example, I might have x to the power 3 in brackets to the power 2. This means that we are going only to do what? To multiply our what? Our powers. So in this case, it's going to be equals x to the power 6, just because I would have said 2 times 3. You just multiply your powers. Then example number 2, you might come across here is this other one which says 2x to the power 3 in brackets to the power 2. Everything is going to be what? To be affected by that index. So it's equal to, this 2 is going to be affected by that index, is equal to 2 to the power 2. Then in this x, I'm going to say x, I will multiply the what? The powers there, x to the power 6. Then I'll proceed here. I'm going to have what? My final answer is, going to be equal to 2 squared is what? That's a 4x to the power 6. So that is my final answer. That is my final answer. Let me proceed to the other theory. That's theory number 5. There is our theory number 5, which says x over a to the power b. Okay, I'm going to apply that theory. Here's my example. It's equal to 3 to the power 2 over 4 to the power of 2. It's equal to 3 squared. That's what? This is not 3 times 2, but it's 3 times 3. For what? For 2 times. So that's 9 over 4 squared. That's what? That's a 16. Most students tend to make a mistake here and say 4 times 2. Otherwise, it's 4 times 4 for 2 times, 3 times 3 for 2 times. That's the meaning. Another example might come is number 5. 2x over 3. Here I might even say squared there. 2x squared over 3 to the power of 3 here. So it's going to be equals to 2 to the power of 3. Then x, this power is going to multiply with what? With 3 to obtain what? A 6 there, over 3 to be affected by what? By a power of 3. I'm going to continue as 2 to the power 3. That's what? That is your 2 cubed, which is 8 x to the power of 6 over 3 to the power of 3 equals what? 27. That is our answer. Let us go to our law number 6. There is our law number 6. A number is raised to a power that is a what? That is a fraction. So it's going to proceed as it's equals to, we are supposed to introduce a what? A root sign there. Then 27. Then this one comes here, 30 root. I'll put what? My brackets. My numerator is going to be that side. So it's equals to, this means that I want a number which multiplies itself 3 times and give me a 27. The number multiplies itself 3 times and gives me 27. So as I said previously, we are supposed to bear in mind what? Those are hints that I gave you. 1 to the power, it's 2 to the power 1 up to 2 to the power 6, 3 to the power 1 up to 3 to the power 5. So if you know that in your mind, you automatically know that here is what? it's a 3, so it's equal to 3 then to the power of 2, so it's equal to 9. It's equal to 9. Then I'll give you that example again. You might find some questions that tend to do what? To combine these theories. That's my number B. I'm going to say 64 to the power negative 2 thirds. If you come across a question like this one, it means that we are supposed to apply that theory. We are supposed to apply that theory that has to do with the what? With a negative sign. Then apply that this current theory that you are doing. So your procedure is going to be like, it's equal to, I'm dealing with that negative. That negative is going to introduce a 1 over, right? Then I'm going to apply my what? My square root to there. I'm going to apply my square root to there. Then 64. Then I'm going to have my third root inside there. Third root. Then like this. Then 2 there. So it's equal to. So I now know that my answer is going to come out as a fraction. So I'll first say 1 over. Then I'm looking for a number that multiplies itself 3 times and give me a what? A 64. That's 4. Then I'm going to square that number. 4 squared. So it's equal to 1 over 16. That is my final answer. That is my final answer. Then there are some cases where you might find a number that is not part of these what? Perfect cubes, perfect squares and the likes. That may require you to do what? To first do some divisions. Let me give you an example. Let me give you an example here. You might find a question having 12 and 27. 12 over 27. This will be raised to a power of maybe 3 over 2. Now what you are supposed to know is that 12 is not part of any perfect squares, perfect cubes and the likes. So we are supposed to first divide 12 and 27 by a single number. In this case, what is our single number that we are going to use to divide 12 and 27? We're going to use what? 3 over 3. Then divided by what? This one, 12 over 27. There to the power of what? 3 over 2. Here I'm just showing you that you are supposed to know that the number that you used on your numerator is the same number that you are going to use on your denominator. So in this case, it's going to be equals to 12 divided by 3. We are going to obtain what? 4 over 27 divided by 3. We are going to obtain what? 9. It's going to proceed like that one. Then your power is going to be 3 over 2. Then we are going to factor in this concept of what? Of a root sign, just because it is raised to a fractional power. So it's going to be equal to, we are going to insert this one as a fraction under our what? Our root sign. So we are going to have 4 over 9 inside there. Then second root. Then I'll put my what? I put my brackets and my power like this and that. Then that's a 3. Then I'm going to continue here. I'm going to deal with them one by one. So it's going to be equal to second root of 4, that's a what? That's a 2 over second root of 9, that's a 3. I'm going to put them together in the what? In that bracket and raise them to a power of 3 since I have a 3 there. So it's equal to, I'm now moving on to what? To my final answer. 2 to the power 3, that's a what? That's a 8 over 3 to the power 3, that's a 27. So this is our final answer. That is our final answer. Let us move to the other theory, theory number 7. Theory number 7, you are now doing just general multiplication and general division. General multiplication and general division. I think I can still do it here. General multiplication and general division. Or number 7, you might find a question saying 2x squared times 3x cubed. So your working is going to be equal to, I'm going to say 2 times 3. 2 times 3, that's a what? That's a 6. Then I'm going to collect these x's, it's x. I'm going to say I'm adding my what? My powers there. So it's equal to 6x to the power of what? Of 5. That is my answer. That is my answer. It same applies when I'm dividing. You might find a question saying 6x to the power 4 divided by 2x to the power 2. So I'm going to say it's equal to 6 divided by 2, that's a what? That's a 3. Then I'll take only 1x and apply my laws of indices. If I'm dividing, I do what? I separate. So it's now 4 minus 2. So it's equal to 3x to the power 2. 3x to the power 2. So that is the end of our laws of indices. Now let's jump into what? Into our question papers that I have here, so that you have an appreciation of what laws of indices are. So let us try to solve some past exam question papers here. I've got November 2003, that's our paper 1. November 2003, that's our paper 1. There is the question. It's number 2, which says evaluate 4 to the power negative 2. Number 2 is what? Item B, 16 to the power 3/4. Then 5 to the power, some fractions there. So let's try to solve those questions. So using my number 1, I'm going to say it's equal to, I'll apply my laws of indices. There is my negative sign. I'm going to say 1 over 4 squared. That's equal to 1 over 16. That is my first answer. I'm now moving on to what? To B, which says 16 to the power of what? 3 over 4. That's equal to root sign, just because it's raised to the power of that is a what? That is a fraction there. Then 4th root here, brackets 3, like that. So it's going to be equal to 4th root of 16, that's a what? That's a 2. Then raised to a power of 3, that's equal to what? 8. So this is your final answer. Then I'll move on to the last one, which is our C. The question says 5 to the power of 2/3 times 5 to the power of 1/3 times 5. Here is a hint. If we come across such a question, we have to know that there is a what? A power of 1. So it's equal to 5 to the power 2/3 times 5 to the power 1/3 times 5. That 5 is raised to the power of what? It is raised to the power of 1. Even though that 1 was not given, you are supposed to know that in mind. Then we'll apply our laws of indices. We are going to add, it's equal to, only take 1 5 is equal to 5 to the power of 2/3 plus 1/3 plus 1. So it's equal to 2/3 plus 1/3, that's a 1 also is going to be 5 to the power of what? 5 to the power of 1 plus 1 is equal to 5 squared. Your final answer is going to be what? 25. Your final answer is going to be 25. So that's equal to 25. That is the final answer. So let's move on to the other question. Here I've got November 2001. Let's try to evaluate this following question from November 2001. There is our number 4. We want to do number 4a, the whole of number 4a. 32 to the power 350. That's 32 to the power of 350. 32 to the power of 350. Then item 2, that's what? 3 to the power 4 times 3 to the power of 0. So here dealing with this 32 to the power of 350, since it's raised to a what? To a power that is a fraction, so it's going to be root sign of what? 32 fifth root there to the power of what? 3. So that's equal to fifth root of that 2, that's what? 2, then to the power 3, that's equal to 8. That is our answer. Then I'll move on to item 2. Item 2, which was saying 3 to the power 4 times 3 to the power 0. There are two methods of working that one. We can apply two distinct methods, but they can still lead us to the what? To the same answer. I'm going to apply both of the methods. Method number 1, anything raised to the power of 0 is equal to what? To 1. So it's going to be 3 to the power 4 times 1. Then 3 to the power 4, that's what? That's an 81 times 1 is equal to 81. The second method, I'm going to say I'm taking a single 3. So method number 2, I'm going to say first 3 to the power 4 times 3 to the power 0. So that's equal to 3 to the power 4 plus 0. That's equal to 3 to the power 4. That's equal to 81. So you choose the convenient method there. You choose the convenient method there. So we're done with the two of these question papers. Let's now move on to June 2015 paper 1. June 2015 paper 1. So move on to June 2015 paper 1. There is our question. It's number 14. It's number 14a. The question says simplify 2a to the power negative 2 times 3a squared. We want to simplify that one. Now that there is a bracket, there is this concept that you're supposed to know. The bracket means that everything that is inside is going to be affected, but there is that negative sign. So I'm going to first apply the concept of a negative sign that's equal to 1 over 2a in brackets to the power 2 times 3a squared. That's equal to 1 over 2 squared a squared times 3a squared, which is equal to 1 over 4a squared times 3a squared. I'm going to introduce what? N over 1 there. I'm going to have equals 3a squared over 4a squared. I'll then do what? I'll then cancel my like term that I have here. It's a squared, a squared. I'm left with what? With 3/4. So my final answer is equal to what? 3/4. That is my final answer. Let's move on to November 2005. There is the question. November 2005. There is the question. The whole of number 3 there. The whole of number 3, we're going to apply our laws of indices there. The whole of number 3. So there is our number 3a. I'm going to first deal with what? With that negative sign. It means that I'm going to say it's equal to x over 3 times 2 over 1 over x squared, right? So it's going to be equal to x over 3. Whenever in mathematics, if you come across 3 terms, what you have to know is that the bottom term, this one, is going to multiply the numerator there. That's a must. You have to know that it's going to multiply there. So in this case, you're going to have times x squared times 2, that's what? 2x squared over 1, like that. So I'm now moving on to what? To my final answer. I'm going to have x times 2x squared, that's equal to 2x to the power of what? 3 over 3 times 1, that's what? That's a 3. So that is my final answer. I'm done there. Let's move on to the other question. The other question is B item 1. B item 1. Our B item 1 says, in this case, I have got 1 over 8 as my B item 1. B item 1, November 2005, 1 over 2 to the power of what? 3. That's equal to 1 to the power of 3 over 2 to the power of 3, that's equal to 1 over 8. That is our final answer. Then the last question, our item 2, which says 9 to the power of what? A half plus 4. I have to first deal with that one, so that's equal to root sign of 9 to 1 plus a 4. It's equal to 3 to the power of 1 plus a 4. It's equal to 3 plus 4, that's equal to 7. So your final answer is what? It's 7. Your final answer is 7 there. Let's move on to the let me try to check the other question here. Okay, I've got June 2015. There is our June 2015. June 2015, that's our paper 2 there. June 2015, I think there is a question there that you are supposed to check. Let's try to check that question out. Okay, so here comes our June 2015. There is the question, B item 1. There is the question. That's our B item 1. Let's try to work that question out. So I've written the question down here. We're going to proceed as equals to, they are both raised to what? To fractional indexes. So I'm going to introduce my root signs there. 27 30 root, then to the power of 2 minus root sign there, 1 over 8 30 root, then to the power of what? 1. That's equal to 30 root of 27, that's a 3 to the power of 2 minus 30 root of 1, that's equal to 1 over 30 root of 8, that's equal to 2 to the power of 1. So it's equal to 3 to the power of 2, that's what? 9 minus half to the power of 1, that's what? That's a half there. Then it's equal to 9 minus half, that's equal to 8 and a half. That is our final answer. That's our June 2015. That's our June 2015. Let's move on to November 2012. That's a replacement paper. November 2012. That's a replacement paper. I think this one was the cheapest. This one was the cheapest. The question says, simplify 2m cubed times 3m to the power 0. That's number 3a. Number 3a, which says 2m to the power of 3 times 3m to the power of what? 0. If anything is raised to a power of 0, there are two methods that I think I showed you previously on which method to apply. In this case, I'm going to apply my simplest method. Is going to be equal to, my simplest method is to convert this m into what? Into 1, just because this 0 is affecting an m. So it's now 3 times 1, that's a 3. Then 2 times 3, that's what? That's a 6. M to the power of 3. That is my answer. That is my answer. Some might prefer to say, working number 2, some might prefer to say 2 times 3 times m to the power 3 plus 0 is equal to 6 m to the power of 3. It's one and the same thing. It's one and the same thing. So these are basically the what? The laws of indices that you are supposed to apply. Then we have got what we call harder indices. Actually, I don't have some question papers here with me, but I've seen such questions from what? From Cambridge examination question papers. You might find a question might appear in the form of a decimal, or it might be raised to a decimal. It might be raised to a decimal. You might find a question saying, number 1 here, the question might say 16 to the power 0, 0.75. You might find a question like that. What you have to know, it's how to convert this 0.75 into what? Into a fraction. I think we did it by the time we were doing what? We were doing fractions. So we now automatically know that 0.75 is what? Is actually what? 3/4. So that's equal to 16 to the power 3/4. Then we apply our basic laws of indices there. 4th root of 16, then to the power 3 is equal to 4th root of 16, that's what? 2 to the power of 3, that's in 8. Then some might come in the form of what? Of decimals alone. Decimals alone. I might say number 2, 0.75 0.25 to the power of 0.5. I have to convert everything into what? Into decimals, into fractions actually, since these are decimals. So it's going to be equal to 0.25 is equal to a quarter. It's a quarter actually. Then raised to a power of what? 0.5, that's a half there. Then I'm going to apply my what? My basic laws of indices, that's a quarter. Then second root to the power of 1, that's equal to second root of 1, that's a 1 over second root of a 4, that's a 2 to the power of 1. So my final answer is going to be equal to a half. That's it. It's going to be equal a half. So these are the basic laws of indices, and these are what we call harder indices. These are what we call harder indices. Sometimes you may come across a question appearing to be like this one. There is this question. It appeared in November 2007, even though I'm not so sure of the actual number, which was saying evaluate. That was we're using 5s there. It was number 1, 5 to the power -2 times 125 to the power it was just 125 here, then it times 5, just like that. What we have to know, if we're dealing with such questions, we have to convert everything to the same base, and every number is supposed to have a power. So in this case, it's going to be equal to 5 to the power -2 times, then I have to convert that 125 using what? Using a 5. As I said, bear in mind those concepts that I gave you as our hints. So in this case, it's going to be 5 to the power of what? Of 3 times. Then that one I'm going to introduce a what? A power that was not there. In this case, it's going to be 5 to the power of 1. I now apply my laws of indices. It's equal to 5 to the power of -2 plus 3 plus 1. So that's equal to 5 to the power of what? Of 2. Then I'm now moving on to what? To my final answer, that's 25. That is our final answer. So those are the what? Those are the laws of indices. What you have to do is to keep in mind what I said are hints. Let's keep in mind those hints. We are going to apply those hints if you are now doing our next topic. Our next topic, we're going to do miscellaneous equations. Otherwise, this is the end of the what? Of the laws of indices. Actually, maybe let me give you the last question that tend to confuse a lot of students. I know a lot of students tend to use a different concept where it is not even applicable. So as a hint, take note of this following question: -64 to the power 2. That's equal to. In this case, this negative sign is on our base, not our power. So we are not, and we will never introduce a what? A fraction there. I'm going to use this -64 as it is in my what? In my square root, -64. Then third root to the power of what? 2. That's equal to third root of a negative number. It's automatically going to be what? A negative what? 4, then raised to a power of what? 2. Now, if a negative number is raised to an even power, we're going to obtain a positive number, just because this is the same as -4 times -4. Your final answer is going to be 16. So keep that in mind. This question is not the same as, it's not the same as this one, which might say 64 to the power -2 over 3. This one requires you to do what? To introduce your fraction. It's 1 over root sine 64 third root, then to the power of 2 is equal to 1 over third root of 64. That's your what? 4 to the power of 2. That's equal to 1 over 16. That is your final answer. So take note of the key difference that is appearing there. Those tend to be maybe some contradicting what concepts when doing laws of indices. So that is the end of our lesson, guys. Let's meet on our next lesson where we'll be doing miscellaneous equations. If we're doing miscellaneous equations, we're going to be applying these laws of indices. So I can say this is the end of our lesson. Thank you for your time, guys.